Hi, this is Tariq Rashid, another class of advanced artificial intelligence. We had the first part of this class, adaptive boosting. It was a theoretical part. This is a practical part, and we will give you an example so that we can understand the implementation step by step of this algorithm. So now, the algorithm starts with initializing the weights. So the initializing the weights would be in a way that, let's say this is our data set, 7 samples. It has 2 features, weather, humidity, and this is the class. -1 do not play and +1 play. So 2 features, 7 samples. Now how we can initialize the weights? Well, we have 7, 1 divided by 7. So each one of them gets 0.1429. So weight for this sample, 0.1429, and the second sample, 0.129, and so on and so forth. So this is 0.149, that sample, 429. This one is 1.1429, and so on and so forth. So these are the weight samples for them. Now, there is a weak classifier which is called decision stump. So decision stump means that the prediction either will be the condition that we hold, which is -1, or otherwise it is plus. And then there are some equations how to find error. This is how to find error, by the way. So this is how to find error. This is the class, and this is the weak classifier. If they are not equal, then it is kind of indicator of error, and that error has to be minimized. So then we will find alpha, which can be found by this equation. You have this error, 1 minus error over error, ln of this amount, and multiply by half. So here we find the alpha, okay? And then the normalization of the weight, it will be what? It will be total weight of the correct classes and incorrect classes. Total weight, sum of the weight of the correct classes and incorrect classes. And the next weight, it will be equal to the current weight multiplied by weight for correct classes over the normalized weight. Normalized weight, that means sum of the weight, normalized. We'll try to solve this example with this one. Now, let's say we defined a candidate weak learner from the decision stump, and if it's -1, then we hold it, and if it's not that variable that we selected, they will be +1. Otherwise, they're +1. So let's take example. We said that we have weather, it's sunny, rain, and overcast. So, for example, we can select one candidate and evaluate. We can select sunny, and hx equals -1 if it is weather sunny. Otherwise, it will be +1. And if there is error, we check the weak classifier. If it's not equal to the class, then it means there is error, and that error will be important for the next to get to a stronger classifier. Now, imagine that we said if if hx is minus 1, equals minus 1, if it's sunny. So if this is sunny, so the y is minus 1, the h would be minus 1, because we said that whether the hx equals 1, according to the equation, hx equals minus 1 if it's sunny. So, so it's sunny, and sunny is holding minus 1, then it is hx minus 1. It's sunny, hx minus 1. High is plus, otherwise we don't care. So rain is plus, otherwise we don't care. And rain, normal, plus, we don't care because they're not sunny. So we care only about the sunny. So rain is minus 1. So our condition is hx equals 1 if it's sunny. So this is a mistake that we have. So it has to be 1, the indicator. Now the overcast, which is not sunny, so if this plus, leave it as it is, leave it as it is. This one, it was sunny, is it is sunny, so hx is minus 1. It is sunny, hx is minus 1. So therefore we have one error here, one error in this example. That one our error, because rain, the output is, the target of it is minus 1, while the condition is hx equals minus 1 if the weather is sunny, otherwise all plus 1. So that's the condition that we hold. And since this one not sunny and it is minus 1, then it cannot be. So the weight, we found it that it is, because there's no error here, 0, no error here, 0, no error here, 0, no error, 0, 0, only this error we have. So it's 0.1429. Okay, so earlier we had all 0.429. Each weight is 0.149. Now we have only one error. So that the cost of that error is 0.1429. We'll check we try to compute eta 1, which is with this formula. We'll see the indicator if y, the output, does not equal the weak classifier. So we'll check all the weights. So in this case, we have only ID6, which is not equal. So ID6, you'll see hx plus and y is minus. So they are not equal. They are not equal. hx and y, they are not equal. The rest are equal. It's fine. So we found the error, plug it into this equation so that we can find alpha, the cofactor, and the alpha was found 0.8959. Now we try to get the normalization with this formula. This is alpha that you have it, plug it in. This is hx, you have it, hx1, they are all in here. And you have the y, which is target, you have it here. We plug them in, and we will try to find z for the first iteration. Now, we find z, and for the z is normalizing weight. So for the next iteration, if I want to find weight for each sample, that equals to current weight multiplied by this formula over the normalized weight. So therefore, I will find the new weight in here, all found through this equation. Okay, you have this, you have this, you have this, and you have this. So you'll find WI for weight 1, weight 2, weight 3, till weight 7, the 7 samples. So So the weights were found, and now we say that's the error that we had. This one was that, and you see the weight here, it is kind of 0.5. It's big, okay? It is big, which means that we need to focus on sample 6 in the data set, okay? And the rest are no mistakes, no errors. Now, end of iteration one, which hx was sunny, -1. We found eta, we found alpha, we found z, and we understand that sample 6 is very, very important for the next iteration. Now, in iteration 2, this is our weight matrix. That's sample 1, sample 2, 3, 4, 5, 6, 7, and that is the error that we had. So this is a very high weight. So it is very expensive, kind of. So now we try to, in this iteration, we try to create, again, we can select candidate, weak learner, and in this case, we will take kind of rain. So H2x, because in iteration 2, H2x, rain equals -1. H2 equals -1 if rain is there. If the condition is rain, then H2x is -1. Otherwise, if it's not rain, then it is +1, the rest of the condition. So here we check our, so sunny is -1, but our condition is rain is -1. So if holds it, -1. If it's not, then this should be plus. So sun is -1, cannot. That is, has to be plus. So that's one error. Sunny, sunny, -1. Again, we selected weak learner as rain. So the condition holding rain. So H2x is -1 if it's rain, and we accept it to be rain, to be selected. No, so sunny -1, this has to be H2 is +1, sunny high, sunny +1, overcast is plus, it's otherwise. So the second condition. So here, this is rain and otherwise. Otherwise, other features, they all become +1. So rain plus, oh, that's a mistake. Rain, we say it should be -1. So here is change. That's the mistake. Rain is +1. That's a mistake because we put the condition rain -1. So, and sunny is -1. It shouldn't be. It should be +1. And sunny is -1. Shouldn't be. So now all together, and this rain, see sample 6, rain is -1, and we have the condition -1, it holds, so this is correct. So nothing changed in the weight, and you can see the weighted error is this one, and this one, and this one, and this one. So we have 4 samples that are errors. Now we collect, we sum up all the errors that we have in 4 samples that we have. So this one and this and this. So ID1, ID2, ID4, and ID5. So we collect all the weights, and we sum of the weights 2 in iteration 2. We plug them here, and we find alpha. Once alpha found, then alpha is 0.342 in iteration 3466 in iteration 2. Now same thing, we try to get normalized weight with this equation, and for correct classification, because correct classification means what? Means plus, so, and or minus. That's the correct classification. But plus minus, that's misclassification. So the misclassification will come here. So the misclassification will come here. So this equals this, that's correct classification. This not equal this, that's wrong classification, misclassification. So here we will find all the, total set for the iteration 2, and then we will update the weight, the next weight, from current weight multiplied by the weak learner multiplied by the class multiplied by minus alpha to the exponential, and then the on the Z2, which is normalized. Now we find weight 3 in iteration 3. So these are the weights. That's wrong, and you can see they are big. Here is correct. You can see it's small. Here is big, correct, big, so wrong. Here is the weight is big, is wrong. And here is correct, and here is correct. And now you can see still 0.35, which was 0.5, but reduced. So that's a good sign. It was 0.5 in first iteration, ID6. Now, this is total results of iteration 2, and we can go with these. We will have difficult samples like 1, 2, 4, and 5. These are needs to be handled. Now, here we have the total updated weights here, and then for the iteration 3, this is the weight matrix that we have. All the these are the mistakes, the wrongs that we have, and we have the weight matrix. Now, then we are still trying to see if there is another value for humidity. We can take it. So let's say we try to take humidity because it has less error. So H3 equals -1 if humidity normal, right? If humidity normal, then Hx is -1. So we'll go through our table, but here, why? Because why we do this one? Because this gives us lowest weight error by having humidity normal. We said that humidity normal. So H3x equals -1. So humidity, that's sunny. This is wrong. Shouldn't be -1 because we say if humidity normal, then -1. So this is it's +1 would be. Sunny, again, minus, that would be +1. So two mistakes now we have. Overcast, it's not humid, so it's fine. Leave it at this, nothing to do. Rain, high, nothing to do because our condition is humidity normal. Then here, humidity normal. These are humidity high, but that high, not accepted because, we are in the humidity. We are in this column. So humidity is holding -1. Hx is -1 if humidity. So that's high. It's minus, so shouldn't hold minus. It will be changed to 1. That's error. The second also error. But high plus, it's fine because humidity normal we took. So that's fine. High plus, again, that's fine, no problem. And normal, humidity normal should be -1, so that's +1. It has to change. That's one error. Humidity normal -1. Yes, we have the condition. It is fine. Should be -1. So it's -1, should be -1. Now, humidity normal +1, that's a mistake. So that's one mistake, two mistake, three mistakes, four mistakes. Again, we will put all the weights of the mistakes and we try to find alpha, and we try to find Z as usual. And these are the Z's fine. We try to update weight for next iteration, and weight for depends on the current weight multiplied by the this formula over the Z, and that's how we have the result. Now, if we have that's um, the total results of iteration 3 for all parameters. Now we're trying to make our final model, prediction model. Well, prediction model equals what? Alpha 1, which we found, hx1, h1x, plus alpha 2 in iteration 2, hx2, h2x, plus alpha 3, h3x. So these are all sum them up. Now we found alpha in first iteration, we found alpha in second iteration, we found alpha in third iteration, which is alpha, which is very little, small, weak learner, is not very strong. Now let's try to have a testing set. Sample 1, we have sunny and normal. Well, in this case, sunny H1 is -1 because we had the first condition, -1. And H2, it was about rain, so it was plus. And H3 is normal, should be -1. So this -1, H3, this is +1, and this is -1. So, and then we multiply, and we'll see what happened. The second sample, rain, well, H1 is about sunny, so that's +1 for the second. H1 is +1. And high, again, this was about the -1, about train. And here is humidity high. That's again +1. Now, for the last one, overcast should be +1 because it was H1 is about sunny, and H2 is it was about +1 should be. It was about rain, and normal, that's -1 for H3. So let's try to do them. So H1 is -1, +1, -1, correct? -1, +1, -1. And H2, so H2, sample 2, H1 +1, -1, +1, +1, -1, +1, and sample 3, H1 is +1, +1, -1, +1, +1, -1. So we plug them in this case is 0.679. This can be rounded to 1. So no play. If you have sunny and normal, no play. And if you have rain and high, the class would be what? Rain and high. The result 0.67, so play. Second sample. Overcast, normal. So here 1.1, that's rounded to 1. So again, play. I think that's more or less about this adaptive boost. It's a great algorithm. It focuses on mistakes and it increases their weights and combine at the end of the day all weak learners to make them strong and strong prediction. Stay tuned for the next algorithm or next subject on artificial intelligence.